Welcome back to the Advanced Microcontroller series. In today's session, let us discuss about microcontroller interfaces with CLCD. In the previous session, we discussed about the introduction and pin configurations. In today's session, let us discuss about communication modes. There is two types of mode, 8-bit mode and 4-bit mode. So let's open the code. So this is the code. Along with the code, let's understand the 8-bit mode. So here we having initialization part. So initially control will go to the init config, then control move to the CLCD code. So here we having CLCD. And here we define the macros. So the data port is connected to the port B and the data direction register of port B is TRISC-D. Sorry, not port B, port D. And RS pin connects to the RE2 and data direction register of RE2 is TRISC-E2, and enable pin which is connected to RE1 and data direction register of RE1 is TRISC-E1. And if your data is data, then you have to write 1, otherwise 0. 0 means instruction. High means 1, low means 0. This one we know, right? This is the simple terms. And this pin configuration we discussed in the previous session. The CLCD is having its own built-in microcontroller. So in the code we use an init display controller. So we need to use data sheet to the initialization, right? So in the PIC we use it PIC16F877A data sheet. But for this CLCD, which data sheet we need to use? Same data sheet? No, right? Because CLCD is having its own microcontroller. So what is the series number of this microcontroller? So here we having HD44780 16x2. So let's search the data sheet. So here we having HD44780 16x2. So this is the data sheet. So here we having the data sheet. So let's know about the initialization. So here we having 8-bit interface and also we having 4-bit interface. So now let's discuss about 8-bit interface, initializing by instruction. So here we having the diagram or figure. So what it's saying, power on. First box or this, what it's saying, power on. So as soon as you power on CLCD, wait for more than 15 milliseconds after VCC rises to 4.5 volt. Another is saying wait for more than 40 milliseconds after VCC rises to 2.7 volt. So in the code we using delay of 30 milliseconds. So we using built-in delay function, that is delay of millisecond. And another one we having delay of microsecond also we having. So this delay is calculating based on crystal frequency. So if you are planning to use any built-in delay function, you have to define this frequency, otherwise you will get error or warning. So what we need to do? We have to define the crystal frequency. So in the code we having one line, this one, hash define underscore external frequency is this much. How much it is? 20 to the power 20 into 10 to the power 6. 20 mega. Frequency means hertz unit, right? Unit of frequency is hertz. So we are using 20 megahertz. So here you can see what is the crystal frequency. We are using 20 megahertz. And after that what we are having? This one, this sequence. So here you can see these are the data lines DB0 to DB7. And also we having RW and RS pin. So RW means what? Read or write. And RS pin. So for 8 data lines. So here we having 8 data lines. So for this we need to write the data. So what you have to write? So here you can see 0011 star 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 star. So what do you mean by star or X? X or star means what? That is the don't care terms. Either you can write 0 or 1. And RW pin we need to set with 0. Read or write. And RS pin, which is also we need to write 0. So here you can see the same thing, right? Sorry, not here. So here RS pin 0, RW pin also 0. So this RS pin which is connected to RE2 means what? RE2 also equals to 0. But here one more pin we having, right? Read RW pin we having here. So here we consider that also equals to 0. But here you can see in the diagram it is already connected to ground. It is permanently connected to ground. So no need to worry about this pin. No need to define this pin here. No need to define the RW pin here. Why? Because it is already connected to the ground. So now usually whatever value you wanted to write for D0 to D7 line, the RS pin for that, so here we using one generic function. So in the code here you can see we used one generic function CLCD write. The same thing here also see CLCD write. So this is the function CLCD write. So here this is for what? RS pin, and this is for data. So here we no need to worry about RW pin which is already ground. So what data you want to write to the port D? So here what it is 0011 star 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 star. So for this can we write 0001 and 0101 like this? Yes, we can write. Why? Because X is nothing but don't care term. So we can write either 0 or 1. Any value you can put. So for that D0 to D7, can we write like this? So whatever you want to write, a byte value you can pass as an argument. So here you can see CLCD write of byte value followed by the instruction mode. Sorry, mode, whether it is data mode or instruction mode. So our aim is to write this one, right? 0 0 0 1 0 1 0 1. So in the generic function CLCD write, can we write directly like this 0x33, 0. 0 means instruction mode. Can we write like this directly? So RS equals to 0, which is nothing but what? Instruction mode. In the macros we define, right? So yeah, can we write like this directly? This is not readable, right? So to make this code, to make this more readable, what we need to do? So the first is what? This is the byte argument and second is the mode. So instead of writing 0x33, so can we write something different? So here for the mode, we assigning the mode value to RS pin and then we assigning port D for port for the data. So here we using port D. So whatever data you want to write, so here instead of writing 0x33, can we define that 0x33 like this? 8-bit mode 0x33, and instead of writing 0x33 directly, can we write like this 8-bit mode instead of 0x33? Yeah, it is more readable, right? So we can write like this. And so now I wanted to print data equals to A. So my aim is to print some data. So whatever data you want to write, take your own time. Once it is done, then what we need to do? Clock the enable pin. So here you can see whatever data you want to write, after it is done, you need to clock the enable pin. So first we keeping as high, then after some delay low. Now CLCD will understand I got complete data. So then it starts processing. But before giving next data, you have to wait until the processing time, right? So we have two methods to find the processing time. One is the delay method and one more is the polling method. But we are not going to prefer the second method because RW is equals to 0, right, in our case. So what we have to do means we are going to use the delay method. For this data, what is the processing time? So how to know the processing time? So do we know what is the processing time? So let's use the data sheet. So here you can see wait for more than 1.4 millisecond. So what is the maximum time required for processing any kind of data? That is nothing but 4.1 millisecond. So to pass any data, that could be data or instruction, we using generic function, that is CLCD, right? We already discussed that one here. So we need to use 4.1 millisecond. The same thing we use it here. But can we write 4.1 millisecond? So instead of writing 4.1 millisecond, so here we use it 4100 microsecond. So to pass any data, that could be data or instruction. Here we using CLCD write, and this one we discussed it, right? What is 8-bit mode? So we defined 0x33 in the macro, and instead of writing that one we return the 8-bit mode, and this is the instruction mode. So now this is what wide init display controller. So let us discuss about this initialization. So initially, so yeah, this function. So initially what we did, initially generated a delay of 30 millisecond. Next we writing CLCD write function. So 8-bit mode means 0x33 and instruction pin. Then wait at least for 4.1 millisecond. And next what we need to do, go to the data sheet, and here you can see this both are same, right? The third and fifth box exactly same. So we using or copying the same instruction. The same instruction we using here also. And next what we need to use, so here you can see wait for more than, sorry, not this, right, this one, wait for more than 100 millisecond. So we need to write the wait, we need to write the delay function. 100 millisecond, no, right, microsecond it is, yeah, 100 microsecond. After that what we need to write, this one. Here you can see this one also same, isn't it? Third, fifth, seventh box all are same. So let's use the same function here also. Next use the same function here also. So after this what we are having, we are not having any kind of delay, right? But for our safer side, we are adding some delay here. Delay microsecond, one microsecond delay we considering here. And what is the next sequence? In the next sequence we having this one. So this sequence is selection of number line or font. So what type of font we are using? So this sequence is what? Selection of number line or font. So in our case, total number of display line is how much? So here we having, this is line 1 and this is line 2. We having 2 lines. In each line we can display 16 character. So let me talk about number of line and font. So let's scroll the data sheet. So what we are searching for? Selection of number lines and font. So whatever character font is there, so here you can see you having a 5x8 dot character font and 5x10 dot character font. So ignore this cursor, okay, ignore this one. So here you can see 1 2 3 4 5 and 1 2 3 4 5 6 7 8. That's why it is 5x8. So how we use it to display G? and this is used for display small letter G. So how to select line or how to select the font? So here we got 5x8 dot character font and 5x10 dot character font is there. So how to select this? So for this, here we having one more, this one. So here you can see function set. What do you mean by n and what do you mean by f? N is nothing but set the number of display lines and f is nothing but set the character font. So what is our question? How to select the font or lines? So here you can see we having one table, right? So what is it? Instruction. The table name is instruction. So what it's saying? So here you can see clear display. So it having so many instructions are there. So let's see one by one. So this is for clear display, return home, entry mode set, display on or off control, cursor or display shift, function set, set CG, RAM, address. So this is what table we having. So if I want to select first line and character for 5x8, then what I need to do? So before that, one more thing I want to discuss. So before this clear display and all, I wanted to discuss one more thing, that this one. So if I want to select line 1 and character for 5x8 dot, what we need to do? We need to use n equals to 0 and f equals to 0. And I want to use line 1 and 5x10 dots. Then I need to use n equals to 0 and f equals to 1. And if I want to select the second line and character font is 5x8 dot, then I need to use n equals to 1 and f equals to star. Star means don't care turn, either use 0 or 1. Now come to the same diagram which we discussed earlier. Yeah, this one. So initially what it telling? 0 0 0 1 1 NF and star star. So here can I write 1 0 0 0? Why 1 0 means n equals to 1 and f equals to 0, because I wanted to use 5x8 dot font and 2 lines. So can I write like this? So here can I write 1 0 0 0? Star means don't care. So what is the hex value of this? So 0 1 1 1, sorry, include this also, DV7, 0011 and 1000. So what is the hex value? 0x38, right? So 0x38, 2 lines, 5 cross 8, 8-bit mode, that is what? 0x38. And so let's define one more macro. So which one? So that is done. Next is the display off. So we don't want to display off. So no need to display off. Next we having display clear. So the same thing we need to write in the code, right? So here we written same thing, CLCD write of 2 lines, 5 cross 8, 8-bit mode and instruction mode. And here we considered delay. So for the safer side we giving delay of 100 microsecond. So here they didn't mention in the data sheet. And what is the next sequence? Next sequence is 0 0 0 0 1 0 0 0 to turn off the display. So here we don't want to turn off the display. Sorry, I said don't want, right? Still I did write it. Sorry, we don't want to turn off the display. So what we need to do? Instead of that, we are using display clear. So before printing any data on CLCD, just make sure it is cleared. So how to clear the display? For that, we are using this 00000001. Use this macro for clear display. So we need to define this macro, clear display screen, and use it here, clear display screen and instruction mode. So after that we are using some delay, and so no need to set entry mode. So after that what we need to use, you need to turning on the display and start cursor off. So here display on and cursor off we are using 0x0C. So that's all about the macro defining. So here same thing we using, after that we considering some delay. That's all about the initialization of init display controller. So this function initialization is done. So let's talk about two built-in function, that is nothing but CLCD, put ch and print. So we having two built-in function. So one is nothing but what? Put ch, CLCD put ch, and one more is nothing but what? Print function. So let's discuss about these two functions now. So why it is used CLCD put ch function? So it is used for printing single character. And why CLCD? Print function, printf function is used. So this is used for print a string. So now let us discuss, sorry, not printf, print, okay, I done printf, right? So print. So how this function is defined? So while of 1 of CLCD, can we write while of 1 equals to open bracket CLCD, put CH. CLCD underscore put CH. Okay, let me write using text. CLCD underscore put CH. So this function. So can we write like this? So it takes two arguments. So what you wanted to print and where you wanted to print. So what you wanted to print, data or instruction, and where you wanted to print, you need to write the address. So CLCD is having two lines, right? We have to pass address. Each line is having its own address. This one we already discussed in the previous session. So here we having 16 characters. So each line is having its own address. It starts like this, 0x80, then this one what, 0x81, 0x82, like this we having for the first line. And for second line we having like this, 0xC0, 0xC1, this is C1 and this is C2, like this we having. This one we discussed in the previous session, right? The same address we need to pass here. CLCD put CH. Now I wanted to print A here, the same place I wanted to print A. So how can I write? So in the CLCD, so here I need to write in place of data I need to write A, and in place of address I need to pass the address 0x80. Now I wanted to print in the third position. So here we having C, right? In this position I wanted to print. Second position address is 0x81 and third position address is 0x82, isn't it? So this is what. Before that, one more thing I wanted to tell. This is what, 0th position, okay, not first position it is. This is 0th position and this is first position, this is second position and this is third position. So just now I said I want to print in the third position. So what is the address? 0x80, 0x81, 0x82 and 0x83. So here I need to write 82. Is it 82? No, I need to write 83. So this is correct to print in the third position. Now if I wanted to print in 15th position, then what I need to write? So for that we defining one macro, that is nothing but line 1 of x, 0x80 plus x, line 2 of 0xC0 plus x. What it mean? Because what it means, so now I wanted to print in the 0th position, means what? 0x80. First position means 1, second position then it is 2, second position means 0x82, third position means 0x83, fourth position 0x84, fifth means 0x85. So 0x80 plus that position, fifth position means 5, 0x85, sixth means 0x86, like that we can find. So 15th position means, so we need to calculate 0x80 plus 15. means how much? 0x95, right? We need to write the address 0x95. The same thing we need to write. So here what we need to write? 0x95 if I wanted to print this data in the 15th position. Now for this CLCD write function, CLCD underscore write off. So here can I write argument like this, data comma data mode? So can I write like this, data comma data mode? So this function will write character A to the CLCD. So here if I write data as A, it will write. But how to CLCD know where I print the character? Here we don't have the address argument, right? So how it will know? Here we passing ASCII value of A to the D0 to D7 line. Data mode means what? D0 to D7 line, isn't it? But don't you think we have to pass the address? Yes, we need to write the address. So for that what we are doing? So for that what we are writing means CLCD write. So what is our function? CLCD put ch, right? Not write. It is CLCD put ch data, and one more argument is address. So in place, so here what we write? What we use it? CLCD write of data comma data mode. So inside this function we can write like this. Why? Because here we define the address, isn't it? No need to write the address again here. So here we define address, that's why we can write like this, data comma data mode. And we can also write like this, CLCD write. So CLCD write of address comma, one more mode is which one? Instruction mode, right? We can write like this. So this is about the putch function. Did you get how to write the putch function? So why it is used? Did you get? So it is used for printing a single character. So it having two argument, what you wanted to print and where you wanted to print. So in the first argument we are defining what you wanted to print, the data we are defining, and second argument we are defining the address. This is about the putch function. And one more function is nothing but which one? So here we need to write the semicolon. Yeah, one more function is nothing but the print function. We discussed it, right? Print, one more function is nothing but print function. So how to write the function? CLCD underscore print. So first argument, so here what is the first argument? String, and second argument is same, address. Now I wanted to print hello. Hello is nothing but what? It is what? It is nothing but string, isn't it? So can I directly like this, write like this, hello, and second is the address. So I wanted to print in the second line and second position. Can I write like this directly, hello, inside the function? So my question, how to collect address? So can I write like this directly? So instead of writing like this, for more readable, So can we write like this? First we need to define the string. So what string you are going to pass? So my string is nothing but what? Hello. So instead of writing directly, to understand the code more readable, can we write like this? First we need to write the string, then we need to pass the same argument inside the function. So here we having CLCD print function, right? So initially we need to write the string. After that, can I write like this? And instead of writing hello directly, can I write like this? String, like this. String is nothing but hello, right? So now my question is, can we write like this? So how many data lines are there? We having 8 data lines. So at a time, how many bit CLCD will process? CLCD can process 1 byte at a time. So it will process 1 character at a time. But here we having how many characters? 5. 5 characters we wanted to print. To print one character, don't you think we need to have a loop? So can we write like this? So instead of writing like this, we need to use any other loop. So I am writing one loop like this. While of, so what? So we having string, right? So I am going to pass the string here. String is nothing but str. So that is not equals to 0. So null. When it is not equals to null, when it is not equals to null, in that time it stops the printing. So here I am going to write this loop. So inside this loop I am going to use the CLCD write function. So I need to pass the address, then I need to pass the mode. So here I am not going to writing directly string. So instead of writing like this, I am going to write the hello. Sorry, not hello, string. So here we need to write like this. This is not pointer. So this is string. So instead of the while function, we are going to write. So here we printing string continuous. So if I wanted to print continuous, we must provide the address. So let me write the loop first, then you will understand how to write. So the same thing here I am going to use. Inside the while function. So CLCD write. So initially we are using address and instruction mode, then data and this mode. So after this I need to increment the string. So here we having 5 element, right? So I need to increment the string. Then what I said, to print continuously we must provide the address. So what we need to do, we need to write address also. So can I write like this? Initially I provided starting address where I want to print the next time. So once the character is printed in CLCD, it will automatically incrementing the address. No need to write again address incrementing. So no need to write again. We just providing the starting address and keep printing the string. So how it will print? Initially it will print H, then it will print E, then it will print L, O, hello. If if there is a null character, so what it's saying, if there is a null character, if condition fails, then coming out of the loop. So this is about the code, the same thing we discussed here, we written here. So here in the CLCD print, we having two arguments, one is string and one is the address. So in the CLCD, right, what we having address and mode, and we also having same loop. And here you can see the same thing we used in the PICSH function also. We having two argument and we passed the CLCD write function. The same thing we used here. And in the CLCD.h, here you can see CLCD PICSH function and CLCD print. Everything is here. And this is the main function. So this is our string. We wanted to print its second line, 0th position. That's all about the code. Let's build the code. Build is successful. Go to the PICSimLab Simulator file, load hexa file. So our code is CLCD 8-bit driver, distributive, default, debug. So one thing, build is not successful. Go to the production, clean and build the project. Let's check now. Load hexa file. Yeah, now we got this. So here you need to pull up the DIP switch. So here it's not printing the output, right? Why it is not printing? So PIC16F877A, go to the file. Again you need to select the file. Before that, check same file we are using. So go to the PICSimLab Simulator. Distributive, default, production and hexa file. So here you can see in the code, in the first line 0th position we are printing H. In the second line 0th position we are printing hello. The same thing printed, isn't it? Same thing printed here in the CLCD. So this is about the CLCD 8-bit mode. And one more is we having, that is 4-bit mode, isn't it? So this is about the 8-bit mode and one more is we having 4-bit mode. So let's open the code for 4-bit mode. So this is the 4-bit mode and here close the previous code. So in the 4-bit mode, what we are doing, we having 4 data lines from DB4 to DB7 instead of using 8. So which one I closed it? Yeah. So instead of using 8 data lines, here we using 4 data lines. So everything is same. So here we using 4 data lines. So here initially byte and 0xF0. First we using upper nibble, then clock enable pin, use some delay, then initially we need to consider enable pin equals to high, use some delay, again enable pin equals to low. And next we need to use the lower nibble, byte and 0x0F, and this one, what it is? Shift operation, right? Left shift by 4. Then again you need to clock the enable pin. So the same for the initialization you need to refer the data sheet. The same thing, little different might be there. Okay, so this is about a 4-bit mode. So production, clean and build project. Go to the file, load hexa file. So this is what, 8-bit mode, right? Sorry, 4-bit mode, right? Distributive, default, production and code. W, world. So one more thing I want to tell, in the CLCD we can't print the integer value. If you wanted to print integer value, then you need to write, for example, I wanted to print 4, then I can't write like this. Instead of writing like this, instead of writing 4 simply, I need to write like a character string. So it is printing only the character, right? ASCII values. So we need to write like this. So yeah, go to the main function. So here you can see in the first line, 4th position, we wanted to print W. So here you can see first 0th position, 1st, 2nd, 3rd, 4th. In the 4th position it's printing W, and second line 4th position it's printing world, isn't it? Same thing. So this is about the CLCD. In our next session, let us discuss about matrix keypad. That's all about today's session. Thank you all.